Okay, so in the single cycle processor, you have to understand that the first instruction is for loading. So first is a fetch instruction part. So let us understand the part where you're going to fetch the instruction here. So you have to understand that first of all our instruction is this. So in here, first this instruction that is will be kind of in this binary format, right? That is the immediate value rs1 f3 rd opcode. This is not to be understood by our computer. So what we have done is that we convert it into the machine language. So this is basically done by whom? This is basically done by the instruction memory. So instruction memory, this instruction is at the address 0x100, and we know how we did this result. When immediate is 12-bit, so minus 4's binary number is this. rs1 is the 5-bit. rs1 is a 5-bit. Now that rs1 5-bit is the source register, that is x9 in binary format. Now function 3 for load, you have to learn that for load our function 3 value for our load, that is 010, is a function 3 value for load. Okay, and rd is a destination register, that is s6, and its 5-bit binary number is given to us as 00110. Then we have the opcode. Now opcode is a 7-bit that is common for all type I, not the immediate part. The load type is the opcode is this, is the opcode that you have to learn like this. Now all this binary number is not understood by the computer, so basically we have to convert into machine language. So the instruction memory basically converts from the program counter, the instruction memory converts this address to the machine language. So what does it do is that you can see here that it converts this address, that is 0x1000, to its machine language format. This much we have understood. Now the next step is what? To read the content in this rs1. Okay, so in rs1 there are some contents in rs1. So whatever the content in the rs1, you are going to take it, we are going to read it through the register file. So through the register file, the instruction is sent to here, and the result, that is the first read result, that is 0x200, has been coming out from the register file. Now you have to understand one another thing is that this 0x2004 is the final content which is present in our register s9. Okay, this has to be subtracted by -4. That is what this instruction say. The contents in x9 is subtracted by -4. So basically the content in here has to be subtracted. So what we do, in order to subtract that content, basically you have to the immediate values here. Now what is the immediate value? We know it is a 12-bit form. So the 12-bit immediate value, that is 1, so you have 1 2 3 4 5 6 7 8 9 10 11 okay, 12. Okay, this is the -4 in binary format. Now grouping it in the pair of 4 pair, if I am grouping this is how I get. So this is f, this is f. Now this is in a hexadecimal form. If I'm writing it, this is f. Now 110 is what? 110 is like 0 0, like 0 1 2 3, right? So 2 raised to 4 plus 8, 12. That is 12. The 12 is what? A, B, C, right? It is 10, 11, 12. So basically this is, so basically it is C. So 0x FFC is this current instruction in 12-bit. Now this 12-bit instruction has to be converted into 32-bit instruction. So in order to convert this 12-bit instruction into a 32-bit instruction is what we use this extender. So this immediate extent, now you get the result here as what? Immediate extent. So from this you are converting this 0xFF6 to the 32-bit form. using the extender here. So here we are using the extender. Yes, we are using the extender here. So basically till now the instruction has been passed to this our register file through this A1, then some other part A2, A3, WD3, WE3. There are some other things here that you have to look, but not now, because in this load we don't want to look that. Okay, the result from here, that is RD1, was 0x2004, which was the content in RS1. The content in RS1 was this. Now again, you have the 0xFC, you use this extender, here, and we got this immediate extent value, that is 0xFFFFFC. Okay, you got this immediate extent value, which is the 32-bit. Now what we have to do, this -4 you have to add in the ALU. In the ALU, you have to add this -4 with this value. That is the next step. So you have to remember that how would be the ALU control value would be what for add. So this values you have to remember. This is basically called as the ALU control value. ALU control for add, subtract, and or and all. So right now, bacha, we are going to learn this ALU control values right now. ALU control values we are going to learn now. So first we have add is 000, subtract is 001, that is 01, then subtract, and is the or is the SLT is the, okay, 001, then 2 values, 010, then 3, 011 for or, right, and for SLT you just write, that is 101. What is this? 4 plus 1, no sorry, it is basically 0 1 2, 2 raised to 2 is basically 4. This is basically actually 5, actually there is no 4 here. So if you see here, this values for the ALU control you have to learn. 000 add, 001 subtract, 010 is and, that is there. Or you have the next value 011 for or and 101 for SLT. So basically here what happened is that the immediate value and 0x2004, there is a result that you have to get. That is, you are going to subtract 2004 with this value to get 2000. Right, this is the ALU result. That is, we are doing addition here. That is why we are using 000. ALU control is 000. Why? Because we are doing here addition. Now you got this result. This result is basically put in the register. You have to write register right. We have to do now, right? So the read data from the memory, we have to read the data from the memory and write it back to the register file. So what you're going to do, we're going to write this to the data memory and we're going to read this data, that is RD. This is write data, this is read data. We have to read this data and put it back into the memory. So this WD3 is why it is used to put the result from this data memory by reading the value and putting it. So from this memory position, that is from this memory position, whatever data is there, that data you have to read and you have to put it back into the register file to the WD3. So this is the main function here. So what does it basically do? What does it basically do? We took from the data memory, we will read the whatever value is there in this. We are going to, there is a write enable, but here write enable is 0 because we are not writing any data into the memory. So here that is why our write enable is basically not given anything. Or reg write is there here. Here reg write is there because whatever result you got it back, you're going to put it back to here. That is why you have this new thing that is called the reg write. Why you have the reg write? Because whatever result you got, you're going to put it back into our register file. You're going to write it. Since we are using this WD3 for writing it, you have to enable this reg write. But here you don't enable the write enable is not enabled here because we are not writing any data in the memory, right? In the load case, we will only write write this data into the register. So we will use only reg right here. Now finally